start by looking at the Pythagorean theorem and its converse. So in order to do that, we need a right triangle. So for our right triangle, we're going to have a leg called A, a leg called B, and the side opposite the 90-degree angle, the hypotenuse, to be indicated with C. Now, using the Pythagorean theorem, we know that in a right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the length of the legs. So knowing that, we get an equation that says c squared, which is the hypotenuse, equals a squared plus b squared. This equation is one you're going to want to write in your notes. Let's do an example. For this example, we're going to find the hypotenuse of a right triangle. So in a right triangle, we have one leg length 4 and one leg length 3. The question is going to be, what is the length of the hypotenuse? Well, we know it's a right triangle, so let's pull out our Pythagorean theorem. Since we want the length of the hypotenuse, we can say A equals 4 and B equals 3, because what we're trying to find is C. So next, we just plug in those values into the equation and let's see what we get. So c squared equals 4 squared plus 3 squared, or 16 plus 9, which equals 25. So c is going to be the square root of 25, or c is equal to 5. Let's look at the converse next. Our original theorem stated that if we have a right triangle, then the hypotenuse squared equals the sum of the lengths of the sides, each squared. Therefore, the converse must be true as well. If we say that the length of the sides squared added together equals the hypotenuse squared, it must be a right triangle. Let's do a quick example to show this. For this example, we are going to verify that a triangle is a right triangle. We are given 3 sides, lengths 5, 12, and 13. The question is it a right triangle? First, pull out your Pythagorean theorem. Next, square the lengths of each of the sides. We can see that if you add 25 plus 144, it is in fact going to equal 169. Since a squared plus b squared does equal c squared, we can confidently say that the triangle is a right triangle. In this example, the hypotenuse is 13, because by definition, the hypotenuse is the length of the longest side. Let's move on to more geometry formulas. This is going to be a section where you're just going to have to write down these formulas into your notebook. Let's start with a rectangle first, and the area for a rectangle is length times width, and the perimeter is equal to 2 times the length plus 2 times the width. Next, triangle. The area is equal to 1/2 the base times the height. Next, we have a circle. The area is equal to pi times the radius squared, and the circumference is equal to 2 times pi times the radius, or pi times the diameter. Then we have this 3-dimensional rectangle, or a cuboid, and its volume is equal to the length times the width times the height, and the surface area is equal to 2 times the length times the height, plus 2 times the width times the height, plus 2 times the length times the width. That was a lot of formulas. Let's go back to our triangles again. In this last section, we're going to talk about congruent triangles and similar triangles. So let's start out with congruent. The word congruent means in agreement or harmony, which I love, but in geometry, we use it to mean identical in form. So equal to. 2 triangles are congruent if each pair of corresponding angles have the same measure and each pair of corresponding sides are the same length. For example, triangle ABC is congruent to triangle DEF. There are 3 ways to determine if triangles are congruent. One way is called angle side angle, and in this case, 2 triangles are congruent if 2 of the angles are equal and the lengths of the corresponding sides between the 2 angles are also equal. Next, side, side, side. 2 triangles are congruent if the lengths of the corresponding sides of the triangles are equal. The last way is side, angle, side. Two triangles are congruent if the lengths of two corresponding sides are equal and the angles between the two sides are the same. Last, let's take a quick look at similar triangles. Starting with the definition, two triangles are similar if the corresponding angles are equal and the lengths of the corresponding sides are proportional. You can see how this is slightly different from congruent, which means equal. Just like with congruent, there are three ways to determine similar triangles. One way is called angle-angle. Two triangles are similar if two of the corresponding angles are equal. Next, we have side-side-side. Two triangles are similar if the lengths of all three sides of each triangle are proportional. And the last of the three ways is a side-angle-side. Two triangles are similar if two corresponding sides are proportional and the angles between the two sides are equal. Let's do one final example of similar triangles. In this example, we have two triangles. We are given that these two triangles are similar. And what we're asked is to find the missing length x and the missing angles A, B, and C. From the definition of similar triangles, we know that all of the angles are going to be equal. Since A is in that same location as the 90-degree angle, we know A equals 90. The same goes for B, so B equals 60. And finally, C equals 30. Unfortunately, finding x isn't as easy, but we do know that all of the sides that correspond are proportional. Since we have two sides, we can set up our fractions or proportions. So we have 3 over 5 equals 6 over x. Once we have our equation, we just solve for x. So we can get common denominator of 5x, so multiply both sides by 5x. We get 3x equals 30. Divide by 3 and x equals 10.